This is a Best Syndication News video production.
Dave Nilsen from the Sheepcreek Water Company spoke to the Zone L Water Advisory Board on November 14th. He told the audience about the company's plan for generating electricity from the natural fall of their water from Wrightwood. This is his presentation.
In the morning until 4:30 in the afternoon. They pay you a premium if you're considered a peak generator. And so that's what we intend to do.
We're going to feed this back into Edison.
Yes. And Edison will let us take the amount of electricity that we're using and they'll subtract it from our bill, and then they'll buy any additional electricity. We're going to probably generate 10 to 15 times the amount of electricity that we're using to pump water out of our 5 wells that we have up in the canyon. So hopefully we'll make a little money to help pay to upgrade our water system, and that's what we're attempting to do. Yeah. But anyway, this is, yeah, I'm getting on since it was his idea. Let's just hold it right here. But anyway, this is where I put down. Oh, wrong side. No, this is up in the close. Anyway, this is where our tunnel is. It's up in the canyon. And we're going to be coming down. Now, we have a pressure sustaining station at what we call Corpender's Pass. It's just below ZLG as you come up over that summit. There's another one where the Scott's residence up in Horse Canyon. And this is where our office is, where our 2 tanks presently, where we're building our 3.5 million gallon tank. This is where we're going to put our first generating plant. And we have the ability to bring a lot of water because we have 1 million gallons of storage up on top of Mr. Zimmerman's property up on Mount Phelan. And we have 1 million gallons of storage at our site. Now our 10-inch line, we can bring down about 1,700 gallons per minute. But we have a 12-inch line from Mount Phelan down to our property. So we can bring up to about 3,000 gallons a minute for a shorter period of time. And we have an engineer at Cal Poly again doing a senior project. He's figuring out exactly how we can maximize the amount of money that we can generate from doing this. And so he's going to be reporting back to us shortly. And we plan on having that tank online by this summer. And we also plan to have the generation facility working by that time. Right now, all that energy is being dissipated in a pressure reducing station, and it can be generating electricity. And so that's what Al asked me to bring and talk about. If there's any questions, I'll be happy.
Well, you could always give tours on that, couldn't you?
Oh, you bet. Well, with my construction class, as they're doing all these projects, it's just across the street. I run them from the high school over there. They see this stuff all the time. And so hopefully they'll get to work a little bit on it too, have some students work on it.
About how big is that generator that you're going to put in? I'd say diameter by length or something like that.
It's actually fairly small. Here's a picture of what it'll look like going into our tank. This is our pressure reducing station just before we put it into the tank. And it's only about 12 by 8 feet. It's fairly small. And what it is just a wheel and the water goes through it. You have to have about 200 PSI coming in. It reduces the pressure down to about 15 pounds, and you generate that into electricity.
So you still have to have pressure regulation even with that's not enough to regulate the pressure.
Yeah, no, we're still going to have to adjust it some. And you're going to see a lot of water companies doing this.
Could you add more onto that then? With that
yes.
kind of pressure, you could go bigger, couldn't you?
And that's what we've got the Cal Poly engineering student working on right now, is how we can maximize this. When we did our preliminary work, we were bringing down 500 to 700 gallons per minute. And now we're bringing down 1,000 to 1,500 gallons per minute. And during our peak demand during the daytime, we're actually bringing more water into the system right now.
So this system is being hooked up going into the tanks rather than leaving the tanks?
Yes. Because that's where the pressure is. Once it goes into the tank, You know, the tanks are approximately 30 foot tall. You have about 15 pounds of pressure at the bottom.
And to start over again.
You start over again. That's right. Yes.
Do you foresee doing a generation system past the tanks, between the tanks and the customers in the future?
Yeah, we sure do. This is the most logical place to put the first one. You know, here in the community of Phelan, we have some people, they don't know if this is really going to work or not. So we have to put in our first unit to make sure that this is going to work. And once they see that it does work, I mean, we've been all over the state and looking at a lot of these plants that are being put in. Once we do our first one, and then we can show them, okay, this is how much it costs and this is how much revenue we're generating. I think you're going to see several of these going on. There's a lot of places. Because we break the pressure down from Sunnyslope, we break it down at Nilsen Road. You know, there's about 200 foot of drop. From Nilsen to Sheepcreek, we break it down again, and then we break the pressure down again at Rancho. So the potential of putting a lot of these in there's a lot of potential there.
Is that where your 3 sites would be that you mentioned?
No, the 3 sites that we have identified now are on our main line that goes from our Desert Front property road down to our Sunnyslope Road. And one is up at Corpender's Pass. The other one is in Horse Canyon. And then the one we've identified is the one where our Sunnyslope property is. And we already have the line. This one, we have the power lines already there. It's a pretty simple thing to install it, and we can plug it in. The other 2, there's power here. This one, we're going to have to run about 1,500 feet of line to get to be able to put it back into Edison's generation. Corpender's Pass.
That's located near
It's just to the west of their Zone G. You go Desert Front, it's probably half to 3/4 miles.
Are there any of the Corpenders still left up there?
I think the daughter's still
decades ago.
Yeah, the daughter's still on. She married a veterinarian in Victorville. I think her name is Holly now, and they still own quite a bit of property there.
Jim, I know we don't have the same exact situation because we pay to pump it uphill, but do we have pressure regulation on any of those lines?
We do have pressure regulation. The problem, what makes Sheepcreek unique for this situation is they don't have any services between their supply and the tanks there. So we can't provide 200 PSI at a house. So Zone L system is really not set up for this type of application. Unfortunately.
Unless we find a well up there that's running 800 gallons a minute, or a spring.
That's right. Well, you know, the one thing that they do, one of the units we went and saw is up at Lake Britain in Northern California. And what PG&E is doing, they take and actually pump water out of the Pitt River at night into Lake Britain. And the lake level rises about 20 feet. And then during the peak time of demand, they run it through a generating plant. And it's cost effective for them to buy the electricity to pump it back in there at nighttime. And then they're generating electricity as it goes out at the peak time. I don't know if that would work.
Devil's Canyon is a real prime example of how they do that, right? And they generate quite a bit of water. I mean, we could look at it.
I just wondered off the top of your head. I know our system isn't exactly, that's like a gift.
See, for us,
It has been for many years.
Yes, that's right.
we'd have to install a lot because of the way Zone L system branches. After the PRVs we have, between that and the next zone, there's probably 35 different pipelines
Branches
coming off
that
the
come
main. We'd have to put PRVs on all of
From the
those.
beginning, it wasn't thought, nobody would have even
No,
thought of it.
no.
Dave, do you know what the kilowatt generation would be?
I think it's about 200 kV at 1,500 gallons a minute. We're hoping to double that. We want to get around 400, which
This has been a Best Syndication News video production.